Let's consider example 2. A loan of L is repaid in the manner $2,000 after 2 years, $1,500 after 1 year, and L divided by 2, 3 years after that, and a final amount of 3,000 another 4 years. So we are told also that the compound interest is 18% per annum and compounded monthly for the first 5 years and 19% per annum annually for the last 5 years. Calculate the initial amount of the loan. We will look at method 1 for our solution. So it is important to take note of everything that we are given. So the first thing is the loan itself. So the loan itself is given, and that loan is L at time 0, and that loan is going to mature after 10 years. The second thing is we know that after 2 years, there was an amount that was paid in order to reduce the value of the loan. So that 2,000 is going to accrue some interest so that at the end of the period, the 10 years, that 2,000 is going to help in clearing the loan. In the third year, we also see that there was an amount that was paid of 1,500. That is also going to acquire some interest and help out in reducing the value of the loan, or rather the balance that is left of the loan. Then after 5 years, this time around, we have to take note of the change that takes place in the interest rate. So this example sort of represents a realistic situation that you may face in life. Then also taking note, in the 6th year, we have L divided by 2 payment that was made, and that is going to also accrue some interest that will help out in clearing the loan. And finally, in the 10th year, when the whole loan is due, an additional or final payment was made of $3,000. So with that, we are going to consider the first 5 years. This is important because in the first 5 years, the rate that was used is different from the rate that was used in the last 5 years. So in the first 5 years, we take note of the loan itself. So the loan was L. So L times 1 plus the rate. So the rate is 18%. So we express it as a decimal according to the formula we're using. That would be 0.18 divided by the periods per year in which the interest is compounded. And if it is compounded monthly, what it does or means is that it is compounded every 12 months in a year. So that is going to be divided by 12. Then we know that in the rest of 5 years, we are going to have 5 times 12 periods. That is to say, in each year we have 12 periods. Then in 5 years, that will be times 5. So now, as before, I would encourage you to make sure that you simplify what's inside the pair of brackets or parentheses. Try to keep it as exact as possible so that you are able to get the exact value or a value that is close to the expected answer that you would have finally. Right, so inside the parentheses, we see that can actually be simplified to 1.015, and that will be raised to the power 60. Of course, we could have just evaluated that, but remember, our goal is to keep our values as exact as possible because we do not want to compromise on the final answer that we would have. If we start rounding up prematurely, it would mean that even our final answer would be an answer that is a bit different, and in some instances, it will be so different from the one that we are expected to get. So that is the value of the loan after 5 years. That is the first 5 years. Now we consider the value of the loan in the last 5 years. We see that the loan has acquired some interest in the first 5 years. That's why it is now L times 1.015 raised to the power 60. Then in the last 5 years, the interest rate changes. So now as the interest rate changes, it means that what we have up until the first 5 years would also accrue some interest for the next 5 years, but at a rate of 0.19 expressed as a decimal raised to the power 5, because we've got 5 years, and this is compounded annually, so meaning that the period is once a year. That's why we just have 5 or raised to the power 5. So we multiply the value of the loan after 5 years times the 1 plus 0.19, which is the interest in the last 5 years, compounded annually, and that is 5 times in total. Therefore, we move on to simplify what we have inside the parentheses, so that we have L times 1.015 raised to the power 60 times 1.19 raised to the power 5. Then, of course, if we want to perhaps simplify things, we may evaluate this. So that would give us 5.8304 L. Now, considering the payments made to clear the loan, so we are going to use the same approach. We have now the value of the loan after 10 years that we obtained. Now we consider the first 5 years. And considering the first payment was made in the first 5 years, implying that the interest rate that is going to be used for the first payment in the first 5 years, or within the first 5 years, is 0.18 in decimals. And we know that this one is compounded monthly. Therefore, we are going to have the 2000 times 1.015, and this is where we have added 1 with 0.18 divided by 12. We simplified that to get 1.015, the same as the one that we obtained for the value of the loan in the first 5 years inside the parentheses. And now we see that this payment was made 2 years after, implying that in the first 5 years, what we would have at that rate is only 3 years. And in 3 years, the total number of periods we would have is 3 times 12. Each year would have 12 periods. So in 3 years, times 3 that. So we get the value in the first 5 years of the first payment. Then we take that value over to the second 5 years, or the last 5 years. We know that in the second 5 years, the rate changes to 0.19, compounded annually. Therefore, that which we obtained in the first 5 years is going to have some interest for 5 years, and that is being multiplied by 1.19 raised to the power 5. And now what we have is what we added, and that is similar to what we obtained in the last 5 years for the loan itself, where we added 1 plus 0.19. Therefore, simplifying that, we are going to get $8,157.22. We move on to the second payment that was made. So in the second payment, we have 1,500 times the 1.015 raised to the power 2 times 12. This is because it was paid in the third year, and at that particular interest rate, the value that was paid, the payment that was made, would be within the first 5 years for only 2 years, and that being compounded monthly. So we are multiplying that by 12, the 2 times 12, so that we get the value of that particular payment in the first 5 years. Then in the last or second 5 years, when the rate changes, we take the value of that particular payment, we multiply it with the 1.19 raised to the power 5, because that is the interest that it would accumulate in the last 5 years. So evaluating that one, we are going to get $5,116.95. Right, so we move on. Before we move on to the next payment, we see that the rate changes, that is beyond 5 years, because we're saying that after the 1,500 payment, there was no other payment that was made in that particular period, the first 5 years. Now we move on to the second 5 years. So in the second 5 years, the payment that was made was L divided by 2. And because it was made in the 6th year, what was left was only 4 years into the period that was considered into the 10 years. So that would imply that we are going to have 1.19 raised to the power 4, the 4 years that were left. And because this was compounded annually, so this one is less complicated than the other calculations that we had to make. So that would give us, when simplified, 1.002p. Right, so then we get to the final payment that was made. Now the final payment is $3,000, and it was made right when the loan was due. So this one is not going to accrue some interest. It would be $3,000 because it was paid on the spot when the loan was due. So if that is the case, then it would mean that the value of the loan in 10 years is equal to the value of the payments in 10 years, because that's how we can find the value of this loan that was given out. Right, so we know what the value of the loan was. The value of the loan was 5.8304 L, which is equal to the sum of all the payments that were made. So these payments are going to have a certain value at the end of 10 years because they also accrued some interest. So we have the first, the second, the third, and the fourth payment. So that is what would give us the value of the loan at that particular time in 10 years. Now that we have that, we move on to solve for L. So if we move the 1.002 L to the left-hand side, we are going to have 4.8284 L is equal to $16,274.17. And of course, since we are trying to find the value of L, L becomes $3,371, and that will be our final answer. A note, this is just one method of solving it. There are many other methods of solving this, so stay tuned so that you don't miss out on any of the methods that we are going to use in solving such questions. Let's look at example